This is the first half of the practice test for Algebra 2, and that's for March 12th, 2021. And hopefully you found this in your big pile of things that I gave you at the beginning of the semester when we came back from distance learning. So here's our little practice test. And for problems 1 through 6, it says simplify each expression and assume that all variables are positive. So no absolute value business. We're done with that. But we can see we still have a lot of work to do on all of those topics that had to do with exponents. So for number 1, we have 343 x to the 6th y to the 12th over 64 x to the 3rd y to the 6th. And I see those big numbers and I think, well, maybe that's reducible. So let's punch that into the calculator and see if 343 64ths is reducible. 343 divided by 64, enter. Math number 1, enter. Ooh, so it's not. 343 64ths is not reducible, but good to check. I also noticed inside there, even though the numbers were not reducible, definitely we could reduce and do a little bit of math with the x's and the y's. So I'm just thinking about the order of operations and that we need to do what's in parentheses first. So 343 over 64 stays put. We could not get that to reduce. But x to the 6th over x to the 3rd, you can either think of it as canceling 3 of the x's from the top and the bottom, or you can remember that division with similar bases is subtraction. So 6 minus 3 will give us x to the 3rd. And then the same thing with the y's. They both have a base of y. To divide those, subtract. 12 minus 6 is 6. Now, those are both positive exponents, so those are supposed to stay on the top with that 343. And we have all of these raised to the 1/3 power. So for the 1/3 power, well, since the root is on the bottom going down into the ground, that's actually cubed root. So let's take a peek at our power chart and see if the cubed root of 343 is something nice. Cubed root, 343, aha, it's 7. And while I'm there, let me look up the cubed root of 64. Cubed root, 64, aha, so 7/4. That's the reason that we couldn't reduce that. We needed to leave it exactly as it was. So we would have a 7 and a 4. And then that 1/3 power, because the variables and the exponents, we deal with those a little bit differently. When you raise a power to a power, you multiply. So I think I'm just going to leave this 7/4 as it is. But I need to have x to the 3rd, the power of 3 has to get multiplied by 1/3. So remember, that's 3 over 1 times 1 over 3. The 3's will cancel, and I'll get x to the 1st, which would just be an x to put up here with the 7. And then for my y to the 6th to the 1/3, we would have 6 over 1 times 1 over 3. And a little quick reducing there would give us a y squared, and it's a positive y squared, so it goes on the top. So you could write it as 7xy squared over 4. You could also write it as 7/4 xy squared. Both of those would be absolutely correct. So there is number 1. Number 2 says we have negative 128 to the negative 3/7. And the first thing I notice is that negative power. And we talked when we were going through these sections about how that's dangerous because people forget it. So first thing to do, make it a reciprocal and a positive power. And then I think, well, negative 3/7, the 7 is the root. So what I really need is the 7th root of 1 over the 7th root of negative 128, and all of that will be cubed. But again, any root of 1 is just 1, so maybe you skip that step and well, that's just going to be a 1. But I need to know the 7th root of 128. And while my power chart doesn't have negatives on there, I know it's going to be the negative of something. And I go to the 7th power, and there it is, and follow it all the way over here to 2. So that's going to be a negative 2. So we have this right now. We took the 7th root, and we received 1 over negative 2, or basically negative 1/2. And now we have to raise that to the 3rd power. Well, again, when we have pure multiplication or division inside parentheses, we can distribute that 3. So think of these as little imaginary 1s, and our answer will come from 1 to the 3rd over negative 2 to the 3rd, because 1 times 3 for those exponents will give us 3. 1 times 1 times 1 is 1. Negative 2 times negative 2 times negative 2 is negative 8. And we'll just put the negative on the top, since it doesn't matter if it goes on the top or on the bottom. And the accepted place to put it is usually in the numerator, on the top. So negative 1/8 for that answer. Let me put some boxes around the answers here. There we go. Number 3. Number 3 is a to the 1/6 times a to the 2/8. And I hope when I said 2/8 you said, oh, wait a second, that reduces. So a to the 1/6 times a to the 1/4. Then we know that when you multiply similar bases, you have to add the exponents. So it's up to you if you want to use a calculator for that. You could put parentheses 1 divided by 6 parentheses plus parentheses 1 divided by 4 parentheses. I'm going to do it the long way, and I'm going to think about the least common denominator for 6 and 4, and that would be a 12. So this fraction will need a 2 on the top and the bottom, and this one will need a 3, and that'll give us a to the 2/12 times a to the 3/12, because to multiply similar bases we have to add the exponents. So that'll be a to the 5/12. But this problem, we have to check, because we're at the end, whether or not it came in radical form or it came with fraction powers, so we'll know if we're done. Well, we're done. It came with fraction powers, so it's a to the 5/12. Let's go to number 4, which has 27x to the negative 3rd, y to the 6th, all to the negative 1/3 power. Well, the first thing I noticed was there's a negative inside those parentheses. So to get rid of that, I'm leaving the 27, which had a power of positive 1 on the top, and a y to the 6, positive 6, but I'm going to move that x to the negative 3rd down to the bottom so that it becomes x to the 3rd. And now all of that is supposed to be to the negative 1/3 power. I can't simplify anything else inside those parentheses. So now I look outside and, oh, negative power, I might miss that. I'm going to go ahead and turn this upside down, find its reciprocal, and then I'll just raise it to the 1/3 power, and that'll work. So now, inside those parentheses, we just have multiplication and division. So that means we can go ahead and distribute that 1/3. And remember, the 27 is to the 1st power. So x, the 3 times the 1/3 will be x to the 1st. And then we'll have 27 to the 1 times 1/3, which would be 1/3 power. And y to the 6 times 1/3, which would be the 2nd power. And then I realize, hey, wait a second. We know what the 1/3 power of 27 is. That's cubed root. So you either look it up on a power chart and say cubed root 27 is 3, or you just remember from all of our work that number showed up a lot. So the cubed root of 27 is a 3, and we have x to the 1st, or just x, we don't need the first piece there, over, shouldn't try to write with the blue, I know better, x over 3y squared. And there it is. So we've got a mix and mash of, different powers, radicals to work with, because remember, fraction powers are another way to write radicals. Number 5 says we have the cubed root of 6 over the fourth root of 6, and you can't do that. One's a cubed root and one's a fourth root. So we have to change that into fraction powers, remembering that the root grows in the ground, so it has to go on the bottom of our fractions. And then we remember, well, to divide similar bases, you have to subtract the exponents. So I look at 1/3 and 1/4, and I realize that my least common denominator is 12. So this one's going to need to be multiplied by a 4 on the top and the bottom, and this one will need a little 3. Or you could grab a calculator and do that subtraction. But we'll have 4/12, 6 to the 4/12, over 6 to the 3/12. And that will give us 6 to the 1/12. But we might not be done. So I look back at the original and I see, oh, this one has to be written as a radical. So we did all the math that we could do with our fraction powers, and now we have to write it as the 12th root of 6. And that's because that 12 in the bottom is the root. The 12 in the denominator is the root. Going on to number 6. All right, number 6. I'm thinking order of operations. I look in the parentheses. Oh, there's some math we can do there, because we're supposed to divide similar bases, and that means you subtract the exponents. 2 minus a negative 8 would actually be 2 plus 8, which is 10. So this is x to the 10th to the 2/5 power. And when you raise a power to a power, you have to multiply. So we need to know what 10 over 1 times 2 over 5 is, and we can do a little reducing here. 5 goes into 5 once and into 10 twice. On the top we'll have 2 times 2, and on the bottom 1 times 1. That's going to be 4 over 1. This is x to the 4th, and that one's done. And again, you could do that multiplication of 10 times 2/5 on your calculator. 10 times, parentheses, 2 divided by 5, parentheses, and get the 4. So you wouldn't have to do that by hand if you don't want to. All right, now we're moving on to the solving. So we were working with the rational exponents as we did in 6-4. And then 6-5, we started talking about solving. And the big deal with these, and it's in the instructions there, check for extraneous solutions. So it's not enough that we just do the problem. We also have to figure out whether or not our solutions are going to work. And our steps for these were isolate the radical and raise it to the power that you know you need to raise it to. And number 7, the radical is also already isolated, and it's a square root. So how we're going to get rid of that is we're going to square. But on the right-hand side, that 2 for a power is closest to parentheses because we need everything on that side squared. So we're going to have to write those down twice and use a little bit of FOIL. So x plus 2 equals x squared, and outside times outside is minus 18x, and inside times inside is minus 18x, so grand total of minus 36x. And then negative 18 times negative 18 is plus 324, which is a large number and doesn't make us incredibly happy. And then we see that we have a squared. And if we have a squared, we have a quadratic. And the way that we solved quadratics was by factoring. So we need to get a 0 on one side because solving is finding the zeros. So we have x squared minus 37x plus 322. And this one is just going to take you some time. There's no greatest common monomial factor. It's not a perfect square trinomial. You're just going to have to sit and work on this one a little bit until you can figure out what those numbers would need to be. And it ends up being negative 14 and negative 23. Those two numbers multiply to 322, and they add to negative 37. So our two solutions are where x minus 14 equals 0, which you add 14 to both sides, and you have x equals 14. And x minus 23 equals 0, you add 23 to both sides. and x equals 23. Now, we have to check. We have to make sure that these are going to work. So, let me find some space here to do that. If we put the 14 in to the original, it's going to say the square root of 14 plus 2 equals 14 minus 18. Well, 14 plus 2 is 16, and the square root of 16 is 4. And 14 minus 18 is negative 4. Uh-oh, that one doesn't work. So 14 is out. We'll come over here and we'll strike it. And then we'll check 23. So let's see what we get for 23. The square root of 23 plus 2, does that equal 23 minus 18? Well, 23 plus 2 is 25. The square root of 25 is 5. And 23 minus 18 is 5. Hey, that one checks. So let me circle that one. That one definitely works. So again, we have to check for extraneous solutions. Let's go ahead and go to number 8, which hopefully I left myself enough space to do. Well, let's see what we have. So this has the quantity 2x plus 1 to the 1/2 equals negative 5. And we realize, well, it does have the radical isolated on one side because 1/2 power is the same thing as square root. So if it bugs you that it has a fraction power, you could write the square root of 2x plus 1. But what we're supposed to say is, oh, that means I have to raise it to the reciprocal power, which would be the 2 over 1 power, which is just 2. So that would give me 2x plus 1 equals negative 5 squared. And negative 5 times negative 5 is 25. And then we'd subtract 1 from both sides and divide by 2. And x equals 12. But we have to check it. So, parentheses, 2 times 12 plus 1. If we raise that to the 1/2 power, are we going to get negative 5? Well, 2 times 12 is 24, and 24 plus 1 is 25. And that's going to be the square root of 25, which is 5. Now, I'm not putting plus or minus 5 down. And even if I did, it still wouldn't be right. And that's because the left side wouldn't equal the right side. But they already had the 1/2 there, which means they wanted the principal root or the positive root. So, well, if that doesn't work, and that's the answer we had, and it was the only one we had, and we did everything right, well, then this one doesn't have any real solutions. Now, wouldn't count on that happening on the test, because on the test we really do want you to see, that something works as you go through there. So this one has no real solutions. See if I can get this into position here. There we go. So number 9, we have the cubed root of 2x minus 4 equals negative 2. Again, the radical is already isolated, so we raise it to the power we know we're supposed to raise it to. To undo cubed root, you'd cube. So that will give us 2x minus 4 equals negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. Then we'd add 4 to both sides and divide by 2. And we have x equals negative 2, but we better check. Things have been going wrong here. So cubed root of 2 times negative 2 minus 4, does that equal negative 2? Well, 2 times negative 2 is negative 4, and negative 4 minus 4 is negative 8. So we need the cubed root of negative 8 to equal negative 2, and 1, 2, 3 slots. It does. Negative 2 times negative 2 times negative 2 is negative 8. So this one's good. Let's go to number 10. Now number 10, we do not have the radical isolated. So we're going to have to divide both sides by 2 before we can begin our process here. And we have x minus 2 to the 2/3 would equal 25. Now, we raise this to the reciprocal power. Come on, Blue. which would be the 3/2 power. And I stop and think. 3/2 power. Something about that says you're supposed to be extra careful. But 2/3 times 3/2, they cancel each other out and you get x minus 2 on the left-hand side. 25 to the 3/2 would be the square root of 25 cubed. Oh, there it is. I had to physically write down the square root symbol. That means I need that plus or minus piece. So x minus 2 could equal -5 cubed, or x minus 2 could equal +5 cubed. Well, let's see what happens. So -5 times -5 times -5 is -125. And then we add 2 to both sides, and x equals -123. And for the second one, we have x minus 2 equals 125, because 5 to the third is 125. And we add 2, and x equals 127. But we have to check. We have to make sure that that's going to work. So let's go up to the original and see what happened. 2 times -123 minus 2 to the 2/3, does that equal 50? And on this one, let's go ahead and punch that in. And let's see, does it work? Just to show you that, yeah, you could use your calculator to check these also. 2 parentheses, -123 minus 2 parentheses to the parentheses 2/3 power. There we go. Delete that little bugger out of there. Enter. We got 50. Well, that's what we were supposed to get. 50 on one side. This one's good. Still have to check the other one. 2 times 127 minus 2 to the 2/3, does that equal 50? Again, let's check and see. And we'll use the graphing calculator, so you know, yeah, you could check with the graphing calculator. 2 parentheses 127 minus 2 parentheses to the parentheses 2/3 power parentheses, boom, 50. Hey, they both work. Excellent. 2 solutions for that one. So we went ahead and I went through 1 through 10 here, and I think that will leave us enough time to get through the rest of these on Monday. But definitely get a little bit of a start on the one review assignment that we have for those 2 days. And that's right here, and it's also in Schoology and multiple places. Maybe do this, do the ones that fit exactly what we had in the review here today. So some things from 6-4 and 6-5 that you find up there, and wait for the others until after we do the practice test on Monday. But have a great weekend, and don't forget, get caught up on those homework assignments. If you don't do your homework, you're not eligible for the retakes, and of course you're not going to do well on the test. So take a few hours off, but if you're behind, make sure you try and catch up. Have a great weekend, everybody.